For the triangle, we've already talked about two. We talked about the circumcenter and the incenter. And I promise there's no more than four. There's just four. The two we're going to talk about today, one's called the orthocenter, the other one's called the centroid. We're going to talk about the centroid first. And the centroid is formed by the intersection of what we call a median. So that's what I have at the top here is just a definition and a little picture of what a median is. So a median, a lot of this is just vocabulary, but what we got today here, a median, it's a segment that connects a vertex. So just one of the vertices of the triangle. So I just grabbed this vertex here to the midpoint of the side across from it, or a midpoint of the opposite side. So remember I was telling you guys when we're going to have questions over this at the end of the unit, I'm just going to give you a blank triangle like this picture was blank before I drew on it, and just say, hey, draw me a picture of a median. And we're not constructing anything here, we're just doing a sketch. So to indicate this was a midpoint, I just kind of eyeballed what I thought was really close to the middle of the segment. I'm sure it's not perfect, but I just put a point there to represent the midpoint. And then to mark it as a midpoint, I marked on either side that those segments would be congruent to each other. And then I just connected that to the vertex. That's one median of a triangle. Each one of the vertices you could draw a median from. So there are actually 3 medians you could draw for any triangle. And we're going to get into that in this information about what we call the centroid. Okay, so the medians, if you draw all 3, and if you want to see it in the picture I have right by this, I do have all 3 drawn into this diagram. So F to H is a median, D to J is a median from a vertex to the midpoint of the opposite side, and G to E is also a median. Yes, I can. There we go. There we go. Okay. Now, I'm going to give you guys, this is the technical definition of this, so I have to give this to you. And you see all these little equations that have 2/3, but I'm going to show you an easier way to do it so you don't have to mess around with the fractions. But the technical definition is going to say the medians of a triangle are concurrent. If you guys remember yesterday, we talked about a point of concurrency is just where 3 or more lines intersect. So when I say they're concurrent, it just means if I draw all 3 of these, they intersect. And that point, it's going to be 2/3 the distance from the vertex to that point. This is called the centroid, which is letter C in that diagram. And then it's 2/3 of the segment from the vertex to that, and then to the midpoint of the opposite side. So I'm going to just draw you a little picture to kind of illustrate that. I'm just going to grab one of the medians out of the diagram. I'm going to use the one that goes from F to H. So F is the vertex, and I'm going to draw a little bit longer line and then a little bit shorter line to represent this. So trying to kind of mimic the drawing there. So if this was F, C is the centroid, that's the intersection of the medians, and H is the midpoint of the opposite side. So what this information is trying to tell you, if we knew the length of the entire segment, from the vertex to the centroid would be 2/3 of that segment, and from the centroid to the midpoint of the opposite side would be 1/3 of the segment. Bless you. And that's just what each of these little formulas say. Now, I'm going to show you just a little bit easier way to do this because this makes the problem, I think, for people easier. Okay, so I'm just going to kind of try and recreate that again real quick. So a little bit longer line from F to C and a little bit shorter from C to H. Okay, now this is how I do these. This has a 2-to-1, if you remember from our similarity unit, relationship between these two segments that form a median. All right, so I'm going to say the whole segment, because this is 2/3 and 1/3, I'm going to show you how to break this apart. I'm going to say the whole segment would be 3x. Okay, to get a 2-to-1 ratio, and this will add up to 3x. If you go from F to C, that's the vertex to the centroid, this would be 2x of the segment, and C to H would be 1x of the segment. 2 and 1 add up together to give you 3. That's still a 2/3 to 1/3 relationship, but mathematically I think this is a little bit easier to work with if you have a problem. So I'm just going to make up a number and show you this real quick. So let's say, I don't know, let's say from C to H was 10. Then from F to C would be 20, and the whole thing would be 30. So the whole median, the two pieces together, there's a 2-to-1 relationship. From the vertex to the centroid is going to be double the smaller piece from the centroid to the midpoint of the opposite side. And then the whole thing together, we would just add those two segments. So most of these problems, they'll either give you the shorter one, you just multiply it by 2 to get the longer one, or they'll give you the longer one, you just divide it by 2 to get the shorter one. It's much easier when we do the actual problem. Okay, now just before we do any problems with this, it says the centroid is also called this is going to be center of gravity for the triangle. And the reason for that is in the middle of the triangle. So if you were to literally take a pair of scissors and cut this triangle out of the notes, if you were to balance your finger on where the centroid is, it would balance out the triangle, so it would lay flat. So the centroid is the center of gravity for the triangle, and because it's the center of gravity, it's always going to be inside the triangle. Always inside. The in-center, the one we talked about yesterday, that's also always inside. The centroid is always inside the triangle. It's the center of gravity for the figure. All right, now the types of problems you guys are going to see are like what I have in example 1. All right, so I'm just going to highlight one of these. So in the directions, it just says C is the centroid for DEF. So each of these segments, F, H, D, J, and GE, this is the same diagram as above. These are medians. So they connect a vertex to the opposite side's midpoint. And it tells me EC here. So I'm just going to highlight the median that involves EC. All right, and then I just take these out of the picture a little bit so I can redraw them. So E to C is the longer part there, and then G is the midpoint of the opposite side. C would be the centroid. So if you want to use what I was just telling you above, it says E to C, this is 16. The vertex to that centroid, this piece for that 2-to-1 relationship, this would be the 2 part. G to C, that would be the X part, so 2 to 1 here. So if this is 16, could you tell me what C to G would be? It is total, it's just 8. So this is the longer piece. This is just exactly half of that. And then if the question asks you what's the, like the whole thing, E to G, which this question does, just add 8 and 16, and that's 24. So ultimately they asked for EG there, so I need to find that 8 to be able to get to it. So for that one, they were giving me the distance from the vertex to the centroid, that's the double part, and then you just cut it in half to get the littler piece. Okay, now the other question is going to involve the median that goes from F to H. So you don't have to do this. If you want to draw it in the picture, you can. I just like to take it out of the picture to work with it a little bit. F is the vertex, C is the centroid again, and H is the midpoint of the side opposite there. So the CH part, this would be the just the 1 in the 2-to-1 relationship, so I'm just going to put an X. F to C would be the 2, so there's your 2 to 1. Now this question says CH is 9. What would you tell me FC is? Go ahead, Thomas. What do you think? 18. All right. So if you have the smaller piece, you just go ahead and double it. And the entire segment, if it asks you for that, just add 18 and 9 together. That's 27. So here FC would be 18, and FH, that's the entire median, just adding 18 and 9 together. That'll give you 27. Is anybody having a question at the moment? It's not really bad. You're either going to have to multiply by 2 or divide by 2. And there's one more thing you might have to do. We'll see that on this next question. Okay. Now, P is the centroid again here. So each of the segments, A to Y, S to R, and T to M, those are medians. So let me see what they give me. They have PR. All right, PR is right here. So that's part of a median. So I'm just going to highlight that whole median really quick there. and it tells me P to R is 6. Okay, just looking at the picture, don't worry about this over here for a second. Could you tell me what S to P would be? 12, done. All right, I'm just going to try to label as much as I can from the given information. Okay, over here it says PT, which is here, so I'll just go ahead and highlight the whole median involved there. So P to T is supposed to be 14. Could you tell me what M to P would be? If P to T is 14, what would M to P? So like this little piece right here. What do you think? Perfect, 7. This is the longer piece, right, from the vertex to the centroid. So you just, if that's 14, just cut it in half. That's 17. Okay, now this one's a little tricky. So AR is actually not on a median. That's just around the outside of the triangle right there. And it says A to R is 9. So not on the median. Can anybody raise your hand and tell me? If I know A to R is 9, what other segment could I figure out in that diagram? What do you think? What would you tell me it is? Not quite. It's tricky. What were you going to say? Yes. Okay, the whole thing would be 18. I know what you were thinking. Yeah, okay. So if you have medians, that means R, Y, and M in this diagram, they're midpoints. They don't really have any markings in the diagram for this. But if AR is 9, R to T has to be the same thing because R is going to be a midpoint in that side of the triangle if we're dealing with medians. So this would be 9. And then the whole side there, we could actually figure that out as well. That would be 18. But that's just on either side of a midpoint, exactly the same length. It's not a median because it's going on one of the sides of the triangle. Okay, now the third thing, or the last thing they give you, the fourth thing, is that AY is 15. Okay, now we have not had one like this. So AY is actually the entire length of a median there. All right, I'm gonna just, let me pull this to the side just a little bit. So I'm gonna redraw that median A to Y there. So A is the vertex, P is the centroid, and Y is the midpoint of the opposite side. Now, they tell me this whole thing is 15. Okay, now, my little 2-to-1 relationship, right? The P to Y, that would be the 1x. A to P would be the 2x. The whole segment, if I add that together, 2x and x, would give me 3x. So if I know the whole thing's 15, could you tell me, like, what would P to Y be and what would A to P be? Or how would I figure that out? Okay. Exactly. Just divide 15 by 3, okay, right? 15 is 3x, so just divide it by 3. Now when you get that, that'll be x, that'll be the littler piece. So what, 15 divided by 3 is 5. So this guy would be 5, and 2 times 5 would make this 10. Add that together, 10 and 15 would totally give you, or sorry, 10 and 5 would give you 15. So if you wanted to put it in the picture here, A to P is 10, P to Y is 5. And then I didn't actually even look at this, so let me actually answer the questions. I think we've labeled everything here. S to P, that was what we labeled with the 12. T to M, that would be, on my paper I colored it in green, that's that whole median. It would be, we'd have to add 7 and 14, so that would be 21. A to T, that was this whole, that's not a median, this is a side in the triangle. A to T, this was 9 and 9, so that was 18 where I put that. And P to Y is this little piece right here that we just found out was 5. So those are the actual answers to the question. But we can label almost every segment in that diagram from the information they gave us. Is anybody having a question about the centroid? Okay, this is the last one. And we're going to talk about, it's called the orthocenter. To get the orthocenter, you draw the height or the altitude, and there's 3 of them from each vertex of the triangle. So in altitude, it's going to be, and this could be like a line, a segment, or a ray. I'm just going to write segment that connects a vertex of your triangle to the opposite side at a 90-degree angle. You guys have seen these before. You have to have the height to be able to find the area of the triangle. Altitude is the same word as the height. They're interchangeable. So it's going to be a segment. It's going to go from your vertex to the opposite side of the triangle, and it's going to intersect it at a 90-degree angle. So you're going to see two perpendicular lines. So if I was sketching this, like I'll give you guys a triangle when we have an assessment over this. I'm going to use this top vertex. Okay, the opposite side from that vertex is just a horizontal line. So I'm just sketching this, but I would just draw straight down. A vertical line and a horizontal line are going to intersect each other at a 90-degree angle. And if you were sketching this for me, I'd want to see that segment, and then I'd want to see that you put the right angle mark in there. We're not constructing this. This is just a sketch. Now, the other thing I want you to notice here, there's nothing really special about this. Like, this does not split the opposite side into two equal pieces. It just doesn't have to do that. I'm just looking for vertex, just drop straight down to the opposite side at a 90-degree angle. If you draw all three of those for any triangle, they will intersect in a point, and it's called the orthocenter. And that's what we're going to write down right underneath here. Okay, so this is going to say the lines that contain the altitudes of a triangle. And I'm going to explain that with the diagrams underneath when I say the lines that contain the altitudes are going to be concurrent, which again, that just means they intersect at the same point. And that point is called the orthocenter. There's really no special mathy thing like we had with the centroid or any, there's nothing like that. It's really just the fact that if you draw all three altitudes, they do intersect each other at a point, and it's called the orthocenter. Now, this is kind of like the circumcenter that we talked about previously, where the orthocenter can be inside, outside, or on the triangle. So I'm going to just show you each case here. If you have an acute triangle, that just means all the angles are less than 90. So vertex to an opposite side at a 90-degree angle. Each one of these is going to be, they just draw them as a ray in this picture here. Each one of these is going to be an altitude. So you see all three of them there, and you see they all run into each other at the point that's called the orthocenter. That is inside the triangle if you have an acute triangle. Now, right triangle, this was kind of interesting. So a right triangle, if I go from the vertex to the opposite side at a 90-degree angle and I have a right angle, that one of the sides in the triangle is also an altitude. Same thing here. Vertex to the opposite side at a 90-degree angle, it's actually just another side in the triangle. Those two sides, they're sides in the triangle, they're also altitudes for the triangle. And then the third one is going to be this guy right here, vertex to the opposite side at a 90-degree angle. The intersection of those three is right in the corner where that right angle is, and so it's actually on the triangle is where the orthocenter is going to be if you have a right triangle. Okay, now for the last one, just give me 1 second. This is a really complicated diagram when you have an obtuse triangle. I'm just going to color the actual triangle that they are drawing the altitudes for in this picture. So this is the actual triangle. If you have an obtuse triangle, the altitude can fall outside of the triangle. So that's why in this it says the lines that contain the altitudes. So for example, I'm just going to highlight this a little bit. Here is a side in the triangle. This is the altitude for that side of the triangle. But what happens here, see these little dotted lines, they have to actually extend the side there to get the altitude. Now, the altitude would just be this little distance right here, and they're just continuing to draw the line so you can see the intersection point. If I do that for, let's see, where's my other one here? Oh my goodness. This one's an altitude here. This one is not outside the triangle. That would go straight down the triangle. The other altitude, I'm going to try to see if I got a different color I can use here. sorry, I'm going to have to use the purple one again. This side, from the vertex to the opposite side at a 90-degree angle, again, that falls outside the triangle, and they have to kind of extend that side with the dotted line. But you can see these guys all end up intersecting. Your orthocenter here is that intersection, and that is obviously outside that triangle. So if you have an obtuse triangle, the intersection of the altitudes is going to be somewhere not in the triangle. It's going to be outside of the triangle. Okay, now we're just going to do this really quick. We're just going to draw the orthocenter. It's not hard, I promise. We're going to draw a triangle first, though, and it has vertices D, E, and F. D is going to be over 2 up 7. E is going to be over 6 up 3. And F is going to be over 1 up 3. And I'm just going to connect the dots to make a triangle. To find any of these points we've been talking about, all 3, for example, altitudes intersect, all 3 medians intersect, all 3 angle bisectors, all 3 perpendicular bisectors. To actually find that point, though, you only need to do 2 of them to find the intersection. You don't have to do all 3. So if I'm trying to find the orthocenter, that's going to be the altitudes that I want to draw. One here is really easy. The other one's going to take a second. So if I look at the side in the triangle from F to E, that's just a nice horizontal line. So to be perpendicular to that, I just got to draw a vertical line. And to draw an altitude, it has to come from a vertex to the opposite side at a 90-degree angle. So if you go to D and just draw straight down, that would be an altitude there. Okay, now I only need one more, but these are trickier because I don't have a vertical line or a horizontal line. So what I want to really remind you of really quickly, I'm going to focus on drawing the altitude for the side in the triangle that's from F to D. You could do either one. I'm just going to do F to D. So if it's not a vertical line or horizontal line, you're just going to ask yourself a really quick question. What is the slope of that segment? So if I just F to D, rise over run, what would you tell me the slope is? Can you guys tell from the diagram? If I go from F to D, rise over run, what's my slope? 4, right? Okay, now I'm just going to write this real quick as 4 over 1. You're going up 4 over 1, right? If we were writing that in the equation, I would write 4. Now, if I want to be perpendicular to that segment or line, what would my slope have to be? 1/4, but you got to, opposite reciprocal, you got to make it negative. Okay, now this is kind of tricky here. So if you want to be perpendicular, we got to go through point E. That's the vertex that's opposite. Okay, now I could go down 1 over 1, 2, 3, 4. I need to go the other direction so I can intersect that segment. So I'm going to go kind of backwards to do this, but I'm going to go up 1, which is positive, but I'm going to go 1, 2, 3, 4 to the left. And then, whoops, I'm going to connect these guys here. It's kind of hard to see with my yellow marker. Let me grab a pen. So I went up 1 over 4. This is the point right here where they intersect. So where those altitudes intersect, that's your orthocenter for this question. It's going to be the point 2, 4. I know that's tricky, but you're just going to use the point, the vertex you want to go through, and the opposite reciprocal slope, and you can either go forwards or backwards depending on the picture, but you're just looking for that intersection point.